and welcome to today's AS Interface webinar, PLC Connectivity, brought to you by Bill Wiedemann, Pepperl & Fuchs, and Schmersel. I'm John Appleson, and I'll be today's moderator. Discussing today's topic will be Fabricio Granados, Director for International Sales at Bill Wiedemann, and Daniel Selgalis, Product Marketing Manager at Pepperl & Fuchs. During the past 12 years, Fabricio has dealt with everything from development to support of AS Interface solutions. He's gained expertise in both theoretical and practical aspects of AS Interface from working extensively with the technology. He is highly competent in the areas of OSI safety, AS Interface analog signals, connecting AS Interface to your PLC, as well as special modules such as counting devices. Daniel Selgalis has 18 years experience in factory automation. His knowledge of Rockwell Automation PLCs has enabled him to offer PLC support for AS Interface and identification products at Pepperl & Fuchs. Currently responsible for those product lines at Pepperl & Fuchs, he's focused on educating and providing the sales team and authorized distributors with all the knowledge required for promoting AS Interface and the AS Interface safety. During the Q&A session, Daniel and Fabricio will be joined by Kartik Bashi, who is an application product manager for Schmersel. Please ask questions as they come to mind at any time during the presentation by typing in the Q&A panel. Our speakers will address them during the Q&A session, or if we don't have time, by email after the webinar. So to get started, I'll hand it over to Fabricio.
Thank you, Jan, for that very good introduction, and welcome to all of you guys for today's webinar about PLC connectivity. The topic of today's PLC connectivity with AS Interface. So if you're expecting something else, you might be in the wrong webinar, but I hope you're all in the right one. So just a little bit of the organizatory stuff before. We've done already a couple of webinars in the past about different topics. The last two ones were optimizing automation with Ethernet and AS Interface, which gives you a very good overview of what is AS Interface and how does it really fit together with Ethernet. The next one was cost analysis and functions of AS Interface safety at work, which gives you a good insight into costs and saving benefits that actually AS Interface brings to your network. There are many other webinars that are also listed on the website of asinterface.net, so I encourage you to just take a look at them, and they're all available on demand. You can just register yourself and listen to all the seminars or webinars and learn also a little bit about that technology. That being said, my topic today is just to introduce you into the integration of AS Interface or an AS Interface gateway into Siemens PLC. My name is Fabricio Granados, as Jan said, working for the company Bill Wiedemann. First topic is actually very simple. An AS Interface master, being a gateway to a different field bus, has just to be handled as any I/O block that you might have out there for whatever field bus. If it's the Ethernet IP, if it's Profinet, Profibus, DeviceNet, SysLink, PowerLink, EtherCAT, no matter which field bus, the AS Interface master is just going to be equal to an I/O block on that field bus. The interesting fact about this I/O block is that it actually represents in the PLC as either 496 digital inputs and outputs, or 256 16-bit analog values, or 62 safety I/O, all basically any combination of those possibilities. That being said, so we have basically just small device in the cabinet that represents a lot of I/O that is actually distributed in the field or also in the cabinet. The integration of such a device into PLC is just as simple as integrating any other I/O block. This means I will guide you through this very simple 5 steps. It's a very rough explanation of what has to be done. If you want to get more into detail and you really want to do this, so most manufacturers have also quick start guides that guide you step by step and give you basically every click that you have to do in that software to get that done. Today I will give you a rough overview of how this system works. First, as in everything, you'll have to download the configuration file to be able to get a description of the device that you want to connect to your PLC. Second step will be to register that configuration file into your PLC system so that it knows what it should be talking to. And after that, you select from that GST you just registered, you will just add the device into the PLC structure or network. You will select, in the case of Profinet, which I/O modules or slots you want to use for that module of communication. And last but not least, we will take a look at the data mapping, how this looks like at the end on your PLC and how to actually use it for programming. That's the first step. So each supplier that delivers a device like this will deliver you as well a GSD file in the case of a Profinet device, or an EDS file in the case of Ethernet P devices, or name it as you want, but we'll talk today only about these two examples, Profinet and Ethernet P. There are many other networks out there where there are also masters or gateways available from different vendors. So in case you don't have today a Siemens PLC or a Rockwell PLC, but you have Backup or ENR or whatever other PLC manufacturer that you're using, don't think that this is not possible to use ACE interface on that network. Please just contact aceinterface.net and search there for actual manufacturer of a device that will allow you to connect into the network, which is inherent to that PLC. So that being said, every manufacturer has a GSD file or a ESD file, EDS file that will make basically a description of the device for the PLC. And the first and very simple step is that I go into the TIA portal and I just actually go into the options and install general station description file, so GSD. I just downloaded it from the website of the manufacturer, or sometimes uploaded it from the device that it was delivered, so there are many possibilities to get that file. And after that, I basically just install it or register it on my PLC. Once that is done, I have it basically in the catalog. As you can see on the right-hand side, there are many devices that are available to my PLC. And I just have to go down to order field devices, Profinet I/O. In this case, we're in the Profinet gateway into the system. And there I have to scroll down to gateway and Bill and Biedermann as a vendor, and to ASI and scroll for the right product that I'm just planning. Once that is done, I can just drag and drop it into my network here at the very top, just to add it to my network. By doing that, I have just added the gateway, and it's just part of my Profinet network. And now, the next step is to tell them this gateway, what data do I want to get out of it? As master we were seeing, there's digital I/O, there's analog I/O, there's safety I/O. Apart from that, there's a lot of different diagnostic information that I can read out of the device. So what I have to do next is to select which information do I want to basically publish on my PLC so that I have it accessible and I can use it in my program or to pass it to an HMI. As you see again on the right-hand side from the GSD file, we have a catalog of the different options that can be selected from the GSD file. We have open here, for example, digital I/O data, and we have different options for digital I/O data. We have also analog inputs, analog outputs in this device. Also, it's a ProfiSafe device that will communicate ProfiSafe onto your PLC in case you have a fail-safe CPU. So you can also select the ProfiSafe data, as well as flags and fault detectors or safety for at work monitor information. So the procedure will be basically as the analog to the procedure before of introducing the gateway. I select the different modules from the right-hand side on the catalog and just include them into the left-hand side of the device overview, the different modules that I would like to access information from. Once I've done it, and I have basically compiled my hardware, which is just to right click on the device itself on the PLC and tell him to compile the hardware. Then I have that device available in my PLC, and I have option to access the information. I hope you guys can see the 3 screenshots good, but basically on this left-hand side, I'm seeing the gateway, Profit.io. I have the different information, and as a difference to Siemens, to Rockwell, Siemens doesn't work directly with tags. It works more with the information as input and output address. As you can see, the first line, I hope you can see it, I introduced 32 bytes of digital I/O data for circuit 1, meaning network 1. And this has an input and output address 0 to 31. This means byte 0 to byte 31. I have basically this amount of data for 32 bytes of data. And the outputs are also bytes 0 to 31. If we relate that to a way it should be programmed, as you can see here, having my network 2, for example, I say here, take a look at input I 2.0, meaning byte 2, bit 0. And then by taking a look at this, we see that in byte 2, the bit 0, we will be looking at D0, the first bit of slave 5. As you can see below that statement 2.0, there's a text says I for input, gateway 1, so which is how I call that gateway. C1 for first circuit. In this case, this is the device that has 2 circuits or 2 networks. SL for slave, 5A for the address of that slave, and bit 0, which is telling me I'm taking a look at bit 0 from slave 5A in the network 1. And I'm just taking a look at that bit to actually go and set an output. This is Q 3.2. 3.2 is just the address of, again, bytes 3, bits 2. And if we take a look at the table here in the top, we're taking a look at slave 7, which is also automatically coming this text. O for output, gateway 1, circuit 1, slave 7, bit 2. This text comes automatically for the GSD file. So in the GSD file, there's also an XML description that basically describes each bit. So when that is done, I can just access the, say that I would access a certain bit, and it will exactly give me a description of which bit from which slave address it is. So I don't have to add any additional text to it. To put that into perspective a little bit and to show you how it looks like in the real life, I just have a picture here for an application. It might be that the application that you have as a supplier or machine builder or end customer is different than this, but this is just a line, could be a packaging line, or most likely it's a packaging line where I have some robots to put some palletizing, put some things into the device. I have a packaging line doing some packaging and moving stuff in and out. If you picture this application, you can just picture all the different devices that can be connected to it. For each particular application, we have safety devices, we have counter modules, we have devices for doing speed monitoring, and different devices that will have different or perform different functions in your system. But we'll just concentrate on this very last part of the option where I have just 2 devices, which basically are 2 simple devices with digital inputs and outputs. And again, we take a look at this example. Take a look at an input, and in case that input is set, please go the action of this robot. Do take a look at if the visual inspection system here tells me that the device that is coming has a fault, is not properly packed, or is not fully packed, so that this robot arm that you see there has to take it and move it away and just put it in a different position. So basically, this is the way that the application works. You program it like this in a very simple way with ladder, taking a look at inputs, normally address as bytes and bits into that byte. And this is just the way it works. To summarize that, through all these 5 steps, what we did basically a very simple PLC integration of a gateway into a PLC, which is as simple as including any other I/O that might be out there into a PLC. We have also at the same time advanced diagnostics, which means at the same time where I put the data, I'm getting cyclic all the I/O data that's available for my PLC, for my HMI. And additionally, I can add information to the cyclic data as flags and faults, which are telling me if there's something going wrong in the device, and lists or different lists that will tell me exactly if something's going wrong, which device it is. For example, if one device gets disconnected, I will get an error that my configuration is not correct, and I will have an access to a list that is going to tell me the device that is causing you that error is going to be slave number 3 on network 1. So you have know exactly what to do. Additionally to that, on Siemens PLC, we also have an acyclic channel that delivers additional information to the PLC as channel diagnostics. Means that if you're looking at the PLC program on TIA, you will be reading directly in clear text. There's an error with the device on Profinet, and that device is saying there's an error on slave 3 on network 1, which has a configuration error. That being said, it's very simple. We know 1 plus 1 is 10 or 10. This is very simple. And that being said, I will pass them now on to Daniel, which is going to basically tell you exactly what I just told you, that in an example for a Rockwell PLC.
Thank you, Fabricio. So, all right, so to get started with the next workflow of the webinar, I wanted to show also the integration of an AS interface gateway into a Rockwell PLC. So AS interface can be used in a variety of different industry applications. The one I wanted to share with you is a material handling application. The material handling application is a good one. It's not to say that this is the only one, but it's a nice one to apply kind of an AS interface type of network and kind of see all the pieces that it makes up. So, you know, really in your worlds, really it could be Ethernet, it could be Profinet at the higher level bus. But as Fabricio indicated, you know, to get to that lower level, be it the sensor and actuator level, an AS interface gateway is introduced intermediate. And the AS interface gateway in this case, since it's a Rockwell application, has an Ethernet IP communication associated to it. The lower level is a material handling application, and I really wanted to stage it in the sense that it shows a network with a yellow cable and a node of sorts of an AS interface node on the actual conveyor. Now the node is defined as a node 1, and with that node it has multiple outputs. It has 2 motors associated to it, and it also has 2 inputs that could be connected as far as photo eyes. So that kind of gives us a sense of maybe just a part of the conveyor, but allows for us to visualize, you know, a larger network consisting of multiple nodes and how these nodes all need to be kind of mapped into this gateway to be recognized. As Fabricio indicated, the gateway is a primary element to get an identity for within the PLC. So given that application, the good news is that our steps for integrating a gateway into a Rockwell PLC don't change much differently than what Fabricio reviewed as far as a Siemens PLC. It is still a 5-step process that I want to outline and go into more detail as it applies to Rockwell PLC. So as far as step 1, again, no use really reviewing that. It's an Ethernet IP application. So we use the Rockwell, in the Rockwell case, in the Rockwell PLC, it's an EDS file that is needed. And the EDS file is an electronic data sheet, and that provides the identity of the gateway within the Rockwell PLC. So this can be downloaded from the various device suppliers of the gateway. So as we open the Rockwell editor up, most Rockwell programmers are familiar with what is called an EDS hardware installation tool. So once the EDS file is located on your computer, downloaded to your computer, it's a simple registration process to register the EDS file. And under the tools option, we would go to the EDS hardware installation tool and get the identity of the gateway represented. So without the first step happening, we would not have any ability within the Rockwell editor to recognize the gateway at hand. So through the EDS file being ported in through the EDS hardware installation tool, we establish an identity of the gateway within the library of the editor. In this case, it's the Pepperl and Fuchs gateway, and there is different options from that EDS file that are able to be found. Very easily, if it was a B.O. Wiedemann EDS file, it would also allow these to be visibly observed in the selection list. So as we establish the selection for one of these gateways to be used, there is different mapping options to consider. So when we look at our highly distributed AS interface network, as we visualize our material handling application, it may consist of simply discrete nodes, and maybe that's all that really the mapping needs to be associated to. So we could pick the first option. But also, as Fabricio indicated, there's the ability to mix both discrete and analog on an AS interface network. So it may justify having even an analog option. In the case of the gateway, certain gateways also have a safety component of it, and that's pretty much the third category of mapping available, which allows some safety status to also be uploaded from the gateway as information is gathered on the AS interface network. Now, one thing also to note is that from an Ethernet side, Fabricio reviewed the ability through the Siemens PLC to make a very granular type of mapping. So it's really on a need basis how many inputs and output nodes or actually bits get associated in that mapping. When you do it with the Rockwell workflow, it is a little bit different because the options that you select, it really produces the full mapping. So the full network, really, if the nodes are getting used or not, will be mapped for you. So with the capacities of AS interface being up to 62 slave nodes, up to a large quantity of discrete nodes, a large quantity of those analog nodes, depending on the mapping that gets selected, it'll give you all that mapping at one time. And the last option, as you're selecting this option, there are different data formats that are important, and I'll speak to that a little bit later about, but in this case, I'm deliberately selecting an integer type of mapping as far as how the information will be mapped in the PLC. These mapping options are determined once again from the EDS file that got ported in during the initial steps. So once our profile or identity of the gateway gets established in the editor, what's very important to note is that there are no descriptions to help you. When I revert back, we have 51 words of input and 51 words of output if we select a particular mapping. That will vary the size of the mapping. As that happens, unfortunately, we don't have any ability very quickly to identify where's node 1, where's node 8 on network 2. So therefore, it's very important to also within the Rockwell environment to create what is called a description file. And that's a nice handy way to populate the column of the descriptions in the editor. So how can this be done? Description files are pretty easy to create. There's a way to create them by just pretty much Some suppliers will have that available for you to port in. It's nothing more than going to the tools option again and performing an import of tags and logical elements if the CSV file is available. The CSV file has to be made available for the data format that you've selected, which is an integer format in our case. 2, it has to be selected for the mapping that you selected as well to make sure that you could get all those descriptions defined. Within the PLC, it could be also done if you need to do it on your own. You could very easily populate those by referencing the user manuals, and that allows for you to populate those accordingly. There is an export option that then creates the CSV file for you in the future then to be able to use for future applications. But again, certain suppliers can provide these CSV files for you such that it makes it very easy to identify your descriptions within the PLC. So given this step, what gets represented in your PLC as this import happens? As your information, as we indicated, this was blank without the ability to import in this CSV file. But with a CSV file, it very easily identifies each node applicable to your mapping. So in our case, we're going to focus on node 1A because that is where our in the material handling application, that's where that module was referenced to. But very easily, if you had a node 3 device, if you had a node 5 device, you could very easily correspond that mapping or that node to a specific tag identifier within your ladder code. So the results of the CSV file that you map populate the description column such that you could very easily identify all the various nodes available on AS Interface Network. So we're going back to our application. In this case, we zero in on this node 1. And this node 1, in any AS interface node, there is a maximum of 4 input bits and 4 output bits. It's always will be mapped as it applies to Ethernet IP. And even if the node doesn't require you to use 4 bits, maybe a certain node has 2 input bits, 1 output bit, those bits will still be mapped in an Ethernet IP case. In this case, this node, be it node 1, has 4 input bits associated to it and 3 output bits. The input bits are where the photo eyes are at, and as those switch states, either being input 2 or 3, that'll trigger that photo eye on that specific module or that specific node within the PLC. As far as the outputs bits, 2 output bits, 0 and 1, are tied maybe to the motors, and that can trigger the motors to get started. A 3rd bit on this particular module even gives you the ability to reverse direction of your rollers. So again, different flexibilities for different nodes specific to the device. As Fabricio outlined the 2 different modules, through the data sheets, you could collect some of this information that allows for you to know how to program it within the PLC. So as far as a sample program, as we take the material handling application and we talked about the 2 bits relevant to the photo eyes and the 2 output bits relevant to the motors, in our case, we develop a very simple ladder code that enables us, as the photo eyes are passed, that will turn on the motors, enabling the conveyor rollers to start moving in a specific direction. Now we also have a isolated node, maybe a node 5, not represented in the diagram, that enables us maybe a push button to reverse or some sort of selector switch to switch the direction of the conveyor. And that is represented by the rung 2 in the sample code. So that is really the summary of showing the workflow associated to a Rockwell integrating an AS interface gateway into a Rockwell PLC. Again, the good news is, as Fabricio and I outlined, the steps are rather identical. It's just being aware of kind of still where those nodes fall and making it applicable to your specific application needs. So we wanted to also at this opportunity also share, as Fabricio indicated, we do a lot of webinars also that enable us to share more and educate you on AS interface. There are some nice workshops coming up that we wanted you to be aware of. The first workshop is actually going to be in 2 weeks from now. At the end of this month, August 30th, we will be hosting an AS interface workshop in Rochester, New York. Another workshop will be, again, strategically located in a little more south. For those maybe closer to that area, this will be hosted on September 20th in Dallas, Texas. And then to end the year, we'll have a third workshop, November 8th, that will be hosted in St. Louis. So we try to strategically position ourselves domestically in the US where it allows for customers to come learn more about AS interface. It really is a nice workshop covering a lot of different topics. The topic we covered with you today is just one sampling of what the workshop provides, but we do go into connecting different suppliers, devices onto a live network, giving you the chance to work with some of the different suppliers' modules, and more importantly, allow you to network with other customers, working successfully with AS interface. So again, encourage you to come to the workshops and learn more about AS interface. And with that, I think the next part of our presentation is questions. So I'm going to pass it to John at this point.
Okay, well, thank you both Danius and Fabricio for your presentations. We'll move into the Q&A portion of the presentation. If you have a question for our speakers, please submit it now in the Q&A panel and then click submit. We've had some come in. If we don't have time to get to your question at this point, we'll answer it afterward by email. So let's bring Kartik in here. We have a question for you, Kartik. Can I do a reset of the AS interface safety monitor from an HMI via the CIP safety?
Thanks, John. Yeah, of course. It's a good question. Yes, it is possible. As Danius and Fabrizio showed you the inputs and outputs of each slaves on the AS interface network. Similarly, the SIP safety output data would come in through the SIP safety, the protocol to the ASI gateway and write it to the safety controller or to the slave to do the reset function. So yes, it can be done, no problem.
Okay, great. Do any of the mapping options in the Rockwell PLC support safety diagnostics? Danius, is that something you can address?
Absolutely, John. So good question. Again, as we discussed the different options, we outlined 3 different available options primarily for an AS interface network in a Rockwell PLC. It's focused primarily on an all discrete type of network, maybe a mix of discrete and analog, and a third option, which is the safety option. So absolutely there is an available, if you have a gateway that supports safety, by all means, that has the ability also to monitor some safety status for you directly from the tags that you have made available.
Good. Can I integrate AS interface into other PLCs, such as Beckhoff or Mitsubishi, etc.?
I guess I'll take that one.
Okay, thank you.
I think that's a very simple question. Yes, of course, there are a lot of different products from different vendors, as I mentioned during my presentation. So if you happen to have a different PLC, your PLC is a Schneider, it's a BNR, Omron, whatever other manufacturers out there, it will have a network that allows us to integrate into that PLC for sure. So just take a look, please, at the asinterface.net website, search for products, and search for that vendor that has the product that will allow you to integrate AS interface into your PLC.
Good. Another question. I don't want to use safety point IO over ProfiSafe as I'm running out of IP addresses in my plant. Can AS interface be used?
I'll take that one, Kartik. Yes, it's a good idea actually that if you are running out of IP addresses, based on each point IO would require an IP address, and in that case, with the AS interface, your IOs can be connected on a single cable, and you will only need one IP address for the gateway that communicates directly to the higher level PLC, or you can have the onboard PLC ASI master on the Siemens PLC. That way you won't even need that. It's right on board that ASI master is located. So it is possible that this is not a problem, and it's a great idea.
Okay, we've got time for a couple more. Danius, this one sounds like something you might be able to provide information on. With PLC integration, do I need to change my gateway mapping if an additional node is added to the AS interface network?
Okay, so great question again. This is one very key benefit I want to stress with AS interface. When we mentioned during the webinar, or I mentioned that every AS interface node has 4 bytes of input and 4 bytes of output allocated to it. But once you go through the possibility of your mapping options, all your nodes on the AS interface network get allocated. Therefore, there's a big benefit here with that, because any new device that gets added to the AS interface network, the mapping is already allocated memory and no programming changes are actually needed. You just pretty much know which locations to reference as new nodes get introduced on the AS interface network.
Okay, we have another question. I am new to ASI as an integrator. I have a few customers recently have introduced me to the technology. I probably have more questions than can be answered here. Current question is, are SST, ASI, SIC cards still supported? Anyone have any thoughts on that?
So I could take that one. The SST cards are more geared at a SLC 500 controller. So the SST we mentioned our focus in this webinar was primarily on a gateway, a remote node. So Fabricio spoke about the remote node of the gateway through a Siemens PLC. I spoke about it through a Rockwell PLC, but there is the ability of a scanner to be a backplane scanner. In the case of an SST scanner, it's not to say that we can't work with you on migrating that to, a more later gateway or even a later scanner. The SST scanners, a number of suppliers have begun discontinuation of that because actually the platform itself is being also discontinued by Rockwell. So I caution that. I encourage you to start, considering a migration plan to migrate to the next generation of a PLC controller, if it's a Siemens platform or even a Rockwell platform.
Okay, thank you. One last question. What kind of diagnostic data are available on AS interface? Fabricio, can you address that?
Oh, I'll give it a try, yes. So that it's a very broad question. There's a lot to say about that. I will just try to summarize it quickly. Yes, in the AS interface, we have intelligent devices. Each device has an ASI, so it has an address itself. So therefore, we can read a lot of information out of it about the status of it and what it is doing. So we would know if slates are connected, if they're having communication errors, for example, if they have not a proper connection or a bad connection. We know if there's something wrong with their periphery, for example, if a sensor supply is overloaded or if I'm missing the power for that device, the auxiliary power. Additionally, we get the overall status of the ASI master. So the ASI master itself publishes also the data to the PLC of what is going on with him and with the devices in his network with up to 16 different flags telling the status of the complete network. And in case of safety, we know also the status of each output circuit, means each system that I built up. But we also get to know which devices are causing the safety basically to shut off or shut down. And in the case there's an issue with any of these devices, what kind of issue it can be. For example, if I have a 2-channel safety input module, if only one of those channels is coming and not the other, and actually both of them should be coming, this will be reflected as an error on the device, and that will be shown directly in the PLC. So in general, like I said, there's a big portion of diagnostics that is available directly in the PLC. And there are also even now some devices available in the market from different vendors that also include OPC UA and web servers as 2 different options additionally to read out diagnostic data out of your ASI network without having actually to go into your PLC program.
Okay, well, thank you, Fabricio, Danius, and Kartik for providing us with so much information, and thanks to our audience for your questions and attending today's event. This presentation will be available shortly in an on-demand format, and as a registered user, you'll receive an email with detailed information on how you can access the on-demand replay of this webinar. Please feel free to invite your colleagues and peers and who may not have been able to attend the event today. The presentation materials are owned and copyrighted by AS Interface, and the individual speakers are solely responsible for their content and opinions. Thank you very much for joining us, and have a great rest of your day.